wave we're discussing, and definitely enjoy it. We are going to be looking at the equation of wave. So that is what I want us to check this. So if you have not heard of this topic before, I will advise you to stay closer. And that is exactly what we have to that is exactly what we have to do. So we are going to be solving series of past questions concerning this. Exactly, series of past questions concerning this. Okay, now, so let us begin. So when it comes to the equation of wave, this is what we have there, where we have y equals to, we have what we call a sine, and from there we are going to have 2 pi x over the lambda in this place. So this is the starting equation of wave. Now from what we have in this place, are different forms in which this equation can be right. So if you are given a wave that has going in this direction, it's moved with respect to time, and as it continues to move with respect to time, so also it displays there. So there's always what we call displacement as it moves through a particular angle. This place represents a pi in this place. Another form that we have there next to it represents another 2 pi continuously like that. Now, under this, it should be noted carefully that from what you have here, this equation can also be rewrite in the form that a sine, then we are going to have 2 pi x over this into bracket, we are going to have x minus dt in this place. The expression that we have in this place showcase how the givens can be right under the given equation of wave. But if we continue to write this expression that we have here, if we continue to write the expression that we have here, if you use this one to multiply this, you use this one here to multiply this, we are going to have y equals to a sine. Use this to multiply this, we are going to have 2 pi followed by x over lambda, close the bracket, minus 2 pi followed by, from what we have there, we are going to have vt over lambda in that place. That is the wavelength. So don't forget that we are actually deriving. That is what we are doing there right now. We are deriving. So the next thing you are going to do, you move to the other hand. So you have to begin to recall some things which are very, very essential. What are those things that you need to recall here right now? You need to recall that if V equals to uh, frequency times the lambda itself, then we are going to have y equals to a sine followed by, we are going to have 2 pi followed by x over lambda, then minus, we're going to have 2 pi. So our v is now f, we are going to have f lambda followed by t over where we are going to have lambda as well. Now, then we are going to have this y equals to a sine into bracket 2 pi x over lambda, then minus 2 pi f lambda t over lambda. Lambda will cancel lambda, leaving behind y equals to a sine into bracket 2 pi x over lambda, then minus, we're going to have 2 pi ft. close the bracket. Now, in this place, recall that omega equals to 2 pi f. Omega equals to 2 pi f. Take note of that. K, wave number, equals to 2 pi over lambda. So you will rewrite this equation, rewrite, take note of that. So we are going to have this expression there. We are going to have y equals to a sine into brackets 2 pi lambda is equal to k. That is kx, then minus, our w is now 2 pi f. We are going to have w followed by t. Close the brackets there. So the expression that you are seeing in this place is also another equation of wave from what we have there. Now, from what you have in this place, there are different expressions you can begin to come across. This expression that you are seeing on the board represents what we call the equation of wave, as you can see. So we have as many as possible. If we proceed, recall that k over w. These are another forms of the expression that we can use to solve. But it should be noted that v equals to f lambda. Okay? But we can also say that f equals to what? F equals to 1 over t. So which you can now rewrite, that is lambda over what? Over t. So where we have v in this place, it can also be replaced. The equation that we have there can also be rewritten in the form that y equals to a sine into brackets 2 pi x over lambda can also be rewritten in the form of what we have, the 2 pi followed by our v now will now be lambda over t followed by what? The small t in this place. The small t there. That is another way to write the equation that we have there. Now, all the expression that we have in this place showcase how we can write a given equation of wave. So there are a series of questions that we can solve here concerning this equation of wave here. Now let us check one or two related questions and see how they are being solved. But before I solve one or two related questions, I will also like to express equation of wave in this written form. Equation of wave can also be written in the form of y equals to a sine into brackets where we have theta minus this expression here. Okay, now where does this originated from? The expression that we have in this place, recall that t equals to where we have theta over w. So if t equals to theta over w, if you recall, and we've already have it earlier that you can cross multiply here, that is w2 equals to theta. From the equation written in this place, this one that we have here, minus wt, so that means everything connected to this can be written in form of what we call theta. You get the point now? So that is the origin of this one here. For this one that we have in this place, which is called the phase angle or phase difference. Where does it originated from? This is where it originated from. The phase angle originated from the expression that we have there, where we have what we call 2 pi x over what? Over lambda, the expression that we have in this place. So phase angle equals to 2 pi x over lambda. So y now equals to 9. Then we are going to have, if you write what you have in that place, when our theta